Till now, we learned a little bit of maths and mathematical ideas in physics and all those things. But from this point, we start with chapter 3, where we learn about motion and all those things. Okay, we start with those things now. Say, really interesting things, much more interesting things to come in mechanics, what we are starting today. I start with that. Just observe the things carefully. Say, we start like this. Say, in this world, whenever you move to your college or school from your house, we say you have moved. And whenever we go from one place to another place, we say you have moved. That means when you move from your house to college, house is the first position. College is the second position. That means your position is changed. That means the movement or motion in physics means change in position. Motion implies change in position. Change in position. That's very important. And if you observe the surroundings where you are, you see many things moving. Many things moving. Say, in the room where you are sitting, air molecules, even though we cannot see them, they are in constant motion, as we said in the beginning, and they are making us to sit comfortably in this room because of their movement. And if you look at the night sky, say all the stars and planets are all moving in one or the other manner. And the blood in our blood veins are moving continuously. That means everywhere we find movement of the things. Say, for our existence, atom is at the base. In atom, electrons are moving. So likewise, everything in one or the other way it is moving. That's why mechanics forms a very important topic in physics. And also, in competitive examinations, mechanics takes a major thing, especially in JEE mains and NEET. Mechanics takes say large scope and more questions will come on that. And also mechanics will help you to improve your thinking ability. It will make you to think in a proper manner, logical manner. It will help you to think in a logical manner. With those things, now we start with. Say, I told you what is motion. Now you said it is change in position. But how do we say where it is? How do we address the position? Very important. Say, whenever a post comes to your, say, whenever a mail comes to your email account, how it comes? Through your email ID or email address, it comes. Or in the normal physical post, from the postman, he delivers some post to your house. How? By looking at the address, such and such a main, such and such a class in the Mysore city at such and such a locality. So that particular addressing is very important. In physics also, addressing a particular position is important because we wanted to say, you have moved from where to where? Your house to school. But where is the house located? Where is the school located? That is to be. Or we say, airplane moves from Mysore airport to Bangalore airport. But where is the Mysore airport? How to locate? Or where is the Bangalore airport? How to locate? And nowadays you are living in the GPS era, global positioning. Wherever you go, if you have a superb phone, you can easily think of where you are in the world. How it all works? Because of proper positioning. That means you can say with a pinpointedness where you are exactly. With some resolution, 200 meters. If you go for the Google, say, map, that will tell you within 200-meter accuracy, within 100-meter accuracy. That goes on telling you like that. Like that. That means in physics also, we require to address the position exactly. Then how do we address? For that, we create what we call as frame of reference. Say, next idea, what we want to learn is frame of reference. Frame of reference. Say, a simple example is in Mysore city, say, your house is at 6 kilometers from Mysore city bus stand. City bus stand is this reference point for all kilometer marking. Like that. Here also, frame of reference. What do we mean by frame of reference? It is just a coordinate system which is taken in this space. Say, right, coordinate system like this. You know, X, Y, and Z. By till 10th, you learned only X and Y coordinates in actually coordinate geometry. But in physics, we take all the three, X, Y, Z, because we are living in the three-dimensional world. So X, Y, Z. And this has the origin. Oh. And onto this side, minus Y, onto downwards, minus Z, onto the other side, minus X. You know how to fix up the coordinates. This coordinate system, with reference to which we can say the position of an object, is what we call as frame of reference. So, in physics, just now we learned what is motion. It is change in the position. And to say the position, we always require what is called as frame of reference. And moreover, an interesting fact, this frame of reference played an important role in development of physics, which made scientists to struggle for almost 100 years to overcome the misconception regarding the frame of reference which was created by Newton, later on abolished by Einstein. That's the beautiful idea that I will take up later on in the laws of motion chapter for the time being. So, what is frame of reference? It is just a coordinate system with respect to which or using which you can pinpoint the particular position. So, that is the thing. And so once you know change in position as the motion, frame of reference as the coordinate system, with all these things, now we continue with the next idea. Say, we imagine a situation. In fact, in mechanics, we require your imagination. As and when I say examples, you try to create those examples as pictures or movies in your mind. Now I'll tell you an instance. If you want, you can close your eyes and try to get the ideas in mind, just movies like that. You create the movies. Say, we are moving from Mysore bus stand to Bangalore bus stand. And there's another idea. When we start from Mysore bus stand, we have an helicopter in which your friend is there. He also starts right from top of the bus stand. And he reaches the Bangalore bus stand. You also reach the Bangalore bus stand. He reaches the Bangalore bus stand on top when you reach, actually where you are going to reach. Now, there's a beautiful idea. You are moving on road. And you know, road, Mysore to Bangalore road, first, actually in that road, first we may actually enter Srirangapatna, later on Mandya, and then say Maddur, Channapatna, and then Ramanagara, finally Bangalore. And the road seems to be curved like this. But does the helicopter move like that? No. It always moves in straight line. There's no need. So helicopter moves in straight path from Mysore bus stand to Bangalore bus stand. So I write that like this. It moves straight. Now, this diagram, this example will help you to identify two things. I will tell those words, just try to think of. First thing, path length. Path length. Second thing, displacement. What all you learned in 9th standard also in your high school classes. Path length and displacement. Say this, I write Mysore and this is Bangalore bus stand. Now, this white color line denotes the route road along which you have traveled in the bus. This orange color line denotes the line along which helicopter traveled, because it will not travel in this way. It travels in straight. Then I call this curved path for the journey from Mysore to Bangalore as path length. Path length along which you traveled. And I call this path of the helicopter from Mysore to Bangalore in straight path, and I call it as, say, displacement of you, not thinking of helicopter, that is also same thing, but observe, I represent that straight path took by helicopter as displacement of you people who traveled along the curved road. Then, can you tell me definition for path length and displacement? Here, helicopter path is the displacement of you who traveled on the curved road. And the path what you traveled is called as path length. So, by looking at, I will give you half a minute or some time, just think over it and so look at the things carefully and create your own definitions regarding displacement and path length. Looking at the diagram, looking at the imagination what you have created in your mind, as I said, this you must be able to. Please write down them in your notebook where you are writing these things if you are writing. Then try to create the definitions for path length and displacement. Please remember, mechanics or the physics for that matter is not the one what we show in the sky. ಕನ್ನಡದಲ್ಲಿ ಒಂದು ಇದೆ. ಕನ್ನಡದಲ್ಲಿ ನಮ್ಮ ಎಸ್ಪೆಷಲಿ ಹಿಂದೂಗಳ ಮದುವೆಯಲ್ಲಿ ಒಂದು ಪದ್ಧತಿ ಇದೆ ಮಕ್ಕಳ. ಏನದು? ಮದುವೆ ಎಲ್ಲ ಆದ್ಮೇಲೆ ಬಹುಶಃ ಮಧ್ಯದಲ್ಲಿ ಒಂದು ಶಾಸ್ತ್ರ ಬರುತ್ತೆ. ಗಂಡು ಹೆಣ್ಣನ ಮಠ ಮಧ್ಯಾಹ್ನ ಮದುವೆ ನಡೀತು ಅಂದ್ರೆ 10:30 11 ಅಥವಾ 12:00ವರೆಗೆ ದಾರೆ ಎಲ್ಲ ಮುಗಿದ ಮೇಲೆ ಗಂಡು ಹೆಣ್ಣನ ಹೊರಗೆ ಕರ್ಕೊಂಡ್ಬರ್ತಾರೆ. ಕರ್ಕೊಂಡು ಬಂದ್ಬಿಟ್ಟು ಗಂಡು ಹೆಣ್ಣಿಗೆ ಅಂದ್ರೆ ಅವನ ಹೆಂಡತಿಗೆ ಆಗ್ತಾನೆ ಮದುವೆ ಆಗಿರ್ತಾನಲ್ವ, ಅರುಂಧತಿ ನಕ್ಷತ್ರ ತೋರಿಸ್ಬೇಕು ಆಕಾಶದಲ್ಲಿ. ಸೂರ್ಯ ಹೊಳಿತಾ ಇರ್ತಾನೆ 12 ಗಂಟೆ 11:15. ಅರುಂಧತಿ ನಕ್ಷತ್ರ ತೋರಿಸೋದು ಹೆಂಗೆ? ಅದಕ್ಕೆ ಐ ಶೋ ಯು. ಆ ಪುರೋಹಿತರು ಹಿಂಗೆ ಇಟ್ಕೊಪ್ಪ ಅಂತ ಹೇಳ್ತಾರೆ. ಸೇ ಹಿ ಹ್ಯಾಸ್ ಟು ಹೋಲ್ಡ್ ಹಿಸ್ ಹ್ಯಾಂಡ್ ಲೈಕ್ ದಿಸ್. ಇಲ್ಲಿ ಹೆಣ್ಣು ನೋಡ್ಬೇಕು, ಆಗ ಗಂಡು ಅಲ್ಲಿ ತೋರಿಸ್ತಾನೆ ಅಲ್ಲಿ ಅರುಂಧತಿ ನಕ್ಷತ್ರ ಇದೆ. ಕೆನ್ ಎನಿಬಡಿ ಸಿ ದಿ ಅರುಂಧತಿ ಸ್ಟಾರ್ at such the midday 11:30 or even at 7 o'clock also? It is not possible in the early morning. So our physics, especially what you learn in the first year, is not like that. We are not showing you the Arundhati Nakshatra because we are learning what you experience in day-to-day life. So this is what you are moving from Mysore to Bangalore. One of your friend moved on the helicopter and you moved on the road. That's a real thing, what is happening in the day-to-day life. Therefore, using this idea, that's why I said mechanics is easy to understand because everything is happening in day-to-day life. Everything is happening in day-to-day life. Therefore, you can recorrelate or you can reconcile your ideas beautifully with the visualizations of day-to-day life aspects. That's why mechanics is most popular subject, most demanding subject, because this forms the basis of all our engineering aspects. Engineering degree ella basic idu makla. That's why very important thing. Okay, with this, now I have by this time, if you are thinking of my question, you must be able to. I will just go for it because if you can switch on and you are actually say audio and you can say it louder. Actual path is the actual distance between 2 points. Okay. And displacement is the shortest path between 2 points.
True path length is the actual path traced by the object.
Okay, that's a nice idea. Few of you said. So we go for it now. Let me tell you. Uh, say path length is actual distance traveled by the bus. Displacement is straight, say change in the position B to A. That is the displacement. Change in the position. Bangalore bus stand minus position minus Mysore bus stand position. That will give you the displacement. In fact, to make you much more clearer in the idea of displacement, it is change in position in a particular direction. If you say just change in position, that itself is enough. But you can say it is change in position in a particular direction. But basically, in the exam, if they ask you, just write change in position. So with that idea, now we'll add path length and displacement. So with those things, I start with these ideas. Right? In today's session, we, especially in the third chapter of this, we start learning about one-dimensional motion only. That means motion on straight line only. I told you, now I used a word, one-dimensional motion. What do you mean by that? Then I will go for this thing. Even though that's not given in the NCERT textbook in the chapter 3, I want to tell you now one interesting fact. You are supposed to create visualization again in your mind. Always, please try to get the pictures in your mind as soon as I say something. Say, if I say, here helicopter is moving from Mysore to Bangalore, you must get in your mind, an helicopter is moving that. Because you know, you have seen the helicopter and it is moving. So you must get that visualization in your mind. Now, I'll tell you. Say, now we will think of what do you mean by one-dimensional, two-dimensional, and three-dimensional. We will learn that. Say, we have tied a string between two walls of your room or 2 points of your room. Then you have kept an ant over that. We have robotic ant. When the robotic ant, we can control it easily. So it is made to move on the string. And you are standing where the string is tied to the wall. And that is our reference point. We take origin. And you are provided with this scale, one scale. And if I ask you after 1 or 2 minutes, where is the ant? So you cannot say it is on the string. You have to tell me particularly where exactly. Then what you do? You say it's at, say, half a meter from my position, sir, on the string. Or it is at 1 meter from my position on the string. So observe, once you say half a meter, 1 meter, like that, you are representing only one number, 1 meter. Where? On the string. That means you require only one number to represent the position of the ant there. That means only one number is required. Now I will give you another. I lift that robotic ant from the string. Now I will keep it on this board. Now I will keep it on this board. I will keep it on this board. That robotic ant. I have not written the ant. If you want, you cannot see. That means I write a big ant there. That's my robotic ant, amoeboic, because it doesn't have any shape. Okay. Now it is made to move on the board. But when it is here, how do I represent the position of it? How do I address the position of it? Hege address ಮಾಡೋದು position. Can somebody tell me? Say no. Angle. How? We'll see. Let me tell you. Here are some of your friends and they are interacting with me. That's why I'm talking to them. Now observe. Say, how do I go for it? Say, if I have fix up a coordinate system over here, then if I imagine this object there, this is the distance at which it is there. Is that enough? It's not possible because it may be R this way, it may be R this way. If you say just only R, say 1 meter here, it's impossible because 1 meter may be in this direction, 1 meter may be in this direction. Then how to do that? For that, you have to tell at which angle it is x, say angle and like that. At which angle it is. That's another way, but it's more advanced. Let's not go for that advanced idea. I want you to do that little easier idea now. Instead of taking an angle, I want you to take x and y axis there, and you can pinpoint the position of the object as x comma y coordinate. You know, all of you know most probably how to mark the points of the topic. So we have a graph. If you imagine x axis and y axis, the portion of the object is x comma y. X comma y. That means, say, 1 meter long x axis, 2 meter long y axis. That means you require two coordinates, two numbers to represent or to designate exactly the position of an object on a plane surface. Board is plane surface where a robotic hand is moving. So when it is here, when anywhere on this board, you require two coordinates, two numbers. Two numbers. Therefore, we say movement on the plane surface as two-dimensional. Two-dimensional. Observe, I am using dimension again, but it is somewhat different from the dimension that we used in the previous chapter. Dimensional analysis is used, but this is different from that. Hereafter, we think of dimension as two ways of 2 points of writing the address, 2 numbers required for addressing. Dimension is the thing like that. So that now that ant, after say something, it has fallen something, we convert it into a beautiful butterfly. That butterfly starts flying in the room where it was sitting. Then how do you identify the position of the butterfly now? Is two positions are two coordinates are sufficient? Two numbers? No, 3 required, because then we add x, y, z. Then we add x, y, z also. This z, say in your room, you fix up the origin at one corner, one side is x, one side is y, and upwards is z. So then, if butterfly is flying in this room somewhere here, you can pinpoint its position by saying 3 numbers, x, y, z. 3 coordinate numbers, x, y, z. Then we call such type of motion where minimum 3 numbers are required to pinpoint the position as 3-dimensional motion. 3-dimensional. So now you learned 1 dimension, 2 dimension, and 3 dimension. 1-dimensional motion is the motion along straight line where we require only 1 coordinate. 2-dimensional motion is motion in plane where we require 2 coordinates to represent the position. And 3-dimension is the one, it is motion in space where we require 3 numbers to say, identify the position. And remember this, these 3 definitions what I have given you now. Can you imagine with a little bit different way of transforming them? Decide how much heat energy required for water to get heated up by so much of degrees. That's a beautiful idea what we take up in chapter say 13. Say, that we think of later on. These things decide about how much heat energy required. That's a beautiful aspect that we think of later on, but for the time being, we learned in this session, say 1-dimensional, 2-dimensional, and 3-dimensional. 1 dimension means motion on straight line. 2-dimension means motion on plane, 2 coordinates required. And 3-dimensional means motion in space. Say, can you generate in your mind an example for motion in 3-dimensional? Apart from bird's movement, airplane movement, butterfly, all they are one and the same. Any other? What is not involving like this? Any other? Just think of it. I will give it as an option for next class. So with that, now, can you anybody tell me? Think of An example for two-dimensional motion. Ship sailing on the water surface is a two-dimensional motion. And when you walk on a flat road, it's a two-dimensional motion. When bus moves in a flat road, it's a two-dimensional motion.
Astronaut in space, three-dimensional.
Definitely. Say, one of my friend is saying, astronaut in the space, it's a three-dimensional, beautiful idea. And likewise, you create some more things, some more examples. Okay, there. For today, just recapitulate what I said. Today we started with that problem, what I think. Now we think of just recapitulation. In mechanics, we learned what is motion, say change in position. Then what is position, path length, displacement. Displacement is change in position, path length is the actual path traveled. After that, we learned one dimension, two dimension, and three dimensional motion. There I conclude this session, my dear friends. Tomorrow we continue with the beautiful mechanics, and what we started today, this goes up to 8th chapter. Or why? Up to 11th chapter it goes. There I conclude today. Thank you.